Guys, welcome to Math Mastery Elite. We're going to discuss the concept of continuity and we're going to solve a few problems so that we would get a better understanding at what is continuity. Now, without any further ado, let us get into the video. Now, let us look at the definition of continuity. A function f of x is said to be continuous at x is equal to c if and only if all the three of the following conditions are satisfied. Now, let us look at the conditions individually. The first condition is that the function value at c exists, that is f of c is defined. The meaning of this function is that at the particular value of f of c, the value should not be infinite. It should be finite and it should be a real number. Now let us check the next point. The limit of f of x as x approaches to c exists. Limit x is tending to c, f of x should exist, it should be finite, and it should be a real number. Now let us look at the third condition and the final one. The limit of f of x as x approaches to c is equal to the functional value at c. That is, limit x tends to c, f of x is equal to f of c. The functional value and the limiting value should equal the same. These are the three conditions that should be satisfied in order to say that the function is continuous at that particular point c. Let's look at the graphs to understand the continuity of a function in more detail. Now this is a function y is equal to f of x such that this curve has no breaks, no jumps, and we can draw this freehand without lifting up n. Now we can say that this function is continuous everywhere within this interval. Now let us check what a discontinuous graph looks like. Now this is a discontinuous graph where we can say that in this interval there are exactly three discontinuous points. The first point is this one, the second is this, and the third is this point. That means we cannot draw this without lifting up n. Now I hope you understood the concept of continuity and discontinuity in terms of graphical representation. Now let us solve a few problems and get a better understanding of the concept of continuity. Now let us check the first question. F of x is equal to x squared minus 1 divided by x squared minus 2 mod of x minus 1 minus 1. At x is not equal to 1 and half when x is exactly equal to 1. That means that the functional value of f of 1 is equal to half. And the limit x is tending to 1 minus and limit x is tending to 1 plus is equal to x squared minus 1 divided by x squared minus 2 of mod of x minus 1 minus 1. Now we can say that the neighborhood of 1, the value of this is the upper function which we've mentioned right here. And the finite value of f of 1 is equal to half. Let us look at the solution of the problem and let us check the continuity of this problem. First, let us look at the left-hand limit. Limit x is tending to 1 minus x squared minus 1 divided by x squared minus 2 mod of x minus 1 minus 1. Since x is less than 0, that means that it should be something in neighborhood of 1, but it is less than 1. That means something like 0.99 should solve a purpose. 0.99 minus 1, but without the modulus, we are going to have a negative answer, right? That means that when x is less than 0, mod of x minus 1 should be represented as minus of x minus 1 in order to make this positive number. Let us substitute the minus of x minus 1 in the place of modulus function. We will get limit x is tending to 1 minus x squared minus 1 divided by x squared plus 2 multiplied by x minus 1 minus 1. And further simplifying, we are going to get x plus 1 multiplied by x minus 1 divided by x minus 1 multiplied by x plus 3. That implies, on cancelling the x minus 1 terms, we are going to get 1 plus 1 divided by 1 plus 3, which is equal to half. Now this is the left-hand limit of the problem. Now let us check the right-hand limit. limit x is tending to 1 plus x squared minus 1 divided by x squared minus 2 of mod of x minus 1 minus 1. This implies that x is greater than 1, but it is in the neighborhood of 1. Okay, now mod of x minus 1 is equal to 1.1 minus 1. Now we're going to get 0.1. That is a positive answer. Now we can say that mod of x minus 1 is equal to x minus 1. Let us substitute the x minus 1 in the place of modulus function. We will be getting x squared minus 1 divided by x squared minus 2 of x minus 1 minus 1. Now on simplifying this, we will be getting x plus 1 into x minus 1 divided by x minus 1 whole square. And this doesn't exist because in the denominator there is 0. The limiting value shouldn't be infinity. And the limiting value approaches to infinity. So that implies it doesn't exist to a particular value. Now, by this we can conclude that the function is discontinuous at 1 and it is left continuous at 1. Then let us look at the next problem. Let us look at the question. F of x is equal to 1 minus sine x divided by pi minus 2x whole square multiplied by log of sine x divided by log of 1 plus pi squared minus 4 pi x plus 4x squared when x is not equal to pi by 2 and when x is equal to pi by 2. When x is exactly equal to pi by 2, the functional value of it is equal to k. That implies we are required to find the value of the limit of the upper function and equal that to k, since that is the limiting value, and it is said that the function is continuous at pi by 2. Now let us find the value of k. First, let us split the limits, and I've taken the first part as 1 minus sine x divided by pi minus 2x whole square. Since this is in the 0 by 0 form, on applying the Hospital's rule, we are going to get a is equal to limit x is tending to 1 sine x divided by 8. We've got to apply the Hospital's rule twice in order to get this result. Now we will be getting a is equal to 1 by 8 since sine pi by 2 is 1. Now let us look at the second part of the limit. b is equal to limit x is tending to pi by 2 log sine x divided by log of 1 plus pi minus 2x whole square, because this expansion right here is in the form of pi minus 2x whole square. Since this is in the 0 by 0 form, we are going to apply the Hospital's rule. We will get b is equal to limit x is tending to pi by 2 cos x divided by sin x minus 4 into pi minus 2x divided by 1 plus pi minus 2x whole square. Now, on solving this, we will be getting cot x multiplied by 1 plus pi minus 2x whole square divided by minus 4 to pi minus 2x. Since this is also in the 0 by 0 form, we can apply the Hospital's rule again. Since this is in the UV form, we can ignore the other term because cot x also approaches to 0. We will be getting minus cosecant square x multiplied by 1 plus pi minus 2x whole square divided by 8. Now finally we will be getting the value of b as minus 1 by 8. And we apply the value of pi by 2. Now on multiplying the a and b, which is the given problem, we will be getting minus 1 by 64. The value of ab is minus 1 by 64. That implies the functional value k is also equal to minus 1 by 64. This is the solution of the problem, and I hope you understood the concept of continuity. Thank you and see you in the next video.